Twitch viewers, the URL for the rest of you is twitch.tv/smAsho. Twitch has a fantastic mobile app, by the way. It will alert you when we go live. We do most of our live streaming on Twitch, but we also do stream live to YouTube. Twitch.tv/smAsho. Twitch is a fantastic mobile streaming platform. It's good enough for gamers, and it's good enough for us, thanks to our new subscribers over on BitChute as well, bitchute.com/smAsho. Thanks to our YouTube subscribers. If you're viewing on YouTube, please don't forget to press the share button, as the algorithms, shall we say, dislike us. And this is our Cosmology segment. So as always, some interesting stories in today's Cosmology segment. Let's get to it. Would you like to buy a $1 million bottle of wine? Well, now this is a 2000 vintage. You may be surprised that a 2000 vintage would fetch $1 million. And I don't think it has fetched $1 million yet, but this wine went to space. And it's wine that's expected to have aged very well. Christie's said Tuesday it is selling a bottle of French wine that spent more than 1 year in orbit around the International Space Station. The auction house thinks a wine connoisseur might pay as much as $1 million to own it. 12 bottles were sent into space in November 2019. It's cosmic ray-induced wine, folks. If you'd like wine with increased cosmic ray flux, this wine has been irradiated for your drinking pleasure. And I believe this is a phys.org article. I'll just let the article scroll. The wine that went to space with the $1 million price tag. Let's talk about Steve. What does it stand for? Well, stimulated strong thermal emission velocity enhancements. Strong thermal emission velocity enhancements, otherwise known as Steve. It looks like an aurora, but it's really not. It's caused by rivers of moving particles emitting light the same way that the aurora emit light, but Steve is a different phenomenon. For some reason, it's associated with picket fence style auroras, as you can see here from an earlier astronomy picture of the day. This is today's NASA astronomy picture of the day for May 5th. Strong thermal emission velocity enhancements, otherwise known as Steve. Great view of a fantastically bright Steve. Great example of that. Again, associated with picket fence auroras, these horizontal parallel lines of auroras. Is that the Hall effect going on there in the atmosphere? Or should I say the mesosphere? Let's talk about radio emissions. Now what you're looking at here are 3 different redshifts. And this object is at a different distance than these two, most likely, as these two are at a redshift of 0.27 and 0.26. This one's at a redshift of 0.73, indicating that it's at a greater distance. It's an odd radio circle. Yes, the radio emissions from this series of galactic cores is odd. And radio astronomy is super interesting, folks. This is at 944 megahertz is the frequency of those radio emissions. And this is associated with radio galaxy NGC 253, known as the Starburst galaxy. There's a great view of that. And we typically see radio galaxies are more viewed edge-on. They are less active in the X-ray spectrum and more active in the radio spectrum. Another article from phys.org, the odd radio circle, noted by the Meerkat Observatory, I believe. the Australian Square Kilometre Array Pathfinder, or ASCAP. So another interesting article there. Let's generate a random number. Today's random number is 819, which coincides with something at the Neil Gorell Swift Bat X-ray Observatory. The Burst Alert Telescope entry 819 is Ginga 1826-238, a low-mass X-ray binary/neutron star, a massive radio source. Probably in the southern hemisphere, as I've never heard of Ginga. In any case, there are the X-ray transient outbursts from this low-mass X-ray binary, and let's take a look at it on SIMBAD. We'll look at it in a few wavelengths here on Aladdin Light. We see a bit of an odd shape going on there. Let's take a look at it on the 2-mass. That's infrared spectrum. The infrared spectrum, this is the heat output from object also known as V4634 Sagittarii. Let's take a look at it in blue light. And there it is in blue light. We see some sort of a odd-looking structure associated with that. And it's apparently quite a bright X-ray source there, as shown by the XMM Newton. What are those odd loops there? We're seeing odd loops of X-ray output there near this object, perhaps associated with it. Pretty interesting. Let's see if it shows up on Pan-STARRS. And there it is on Pan-STARRS, one of the higher resolution pieces of imagery you might get of this object. Again, it's entry 819. Ginga 1826-238, the low-mass X-ray binary/massive radio source believed to be a neutron star. And here's yet another article about pulsars, as some new pulsars have been discovered. Here at the Smash News Network, least busted name in news, we're interested in pulsars. Rapidly rotating massive radio sources. This is an artist's rendition of one, as if you're viewing it from the pole. And stellar spots is one of the explanations of how these pulsars do what they do. This series is a study of some globular cluster cores. So apparently some pulsars being found looking at 9 different globular clusters. New pulsars discovered in 6 of them. So this is a SciTechDaily.com article. This one will probably be all over the Science Wire as well, as the Meerkat Observatory discovers 8 new millisecond pulsars. Cheers, pulsars. And that's the end of today's Cosmology segment. Thanks to our Twitch viewers, and wherever you viewed it, please share the videos on your social media. Tell your friends and foes about the channel. And we'll see you next time. And we'll invite you back Twitch for our meteorology segment.